Thank you, and let's go ahead and get started. So the Caribou Monitoring Unit works to support woodland caribou recovery in Western Canada. Like ABMI, a lot of our work does happen in Alberta, but we also work quite a bit in Saskatchewan, BC, Northwest Territories, and the Yukon. So we have a Western Canadian focus. Our work really fits into three different bins. The first is research, largely applied research with some theory and theoretical spin that really aims to understand the mechanisms behind caribou declines, how landscape change influences predator-prey dynamics, and how that kind of translates into caribou declines. The second bin is prioritizing habitat restoration across landscapes within and between caribou ranges. So I'll get into that a little bit more later. I won't go into detail now. The third bin, which kind of encompasses the second, but is kind of all on its own as well, is testing recovery options. So what are the management actions that are available for recovering caribou populations, and really testing the efficacy of all of those different management and recovery options. Not doing the actions ourselves, but providing the science and communication to test and understand the efficacy of those actions. Now, I'll start with why are we here and talking about caribou? Caribou they have a pan-Canadian distribution and are declining across much of their range within Canada. Here on this map, you can see the different designatable units of caribou, so things like barren ground, boreal populations, or central mountain in different colors. You can also see the historic range of caribou in the dashed line, and you'll notice that the population has retracted northwards. In Alberta, we're mostly talking about boreal populations as well as central mountain populations. And these caribou overlap areas with high resource value for humans, things like forestry and oil and gas deposits. And caribou typically live with a wide distribution and low population densities. In recent history, there have not only been declines in individual caribou populations, but also extirpations of populations. So going back to 2003 with the George Mountain population, and most recently, you may have seen in the news in 2020, the Melanie population has gone extirpated. So there's an urgent need to understand the causes of caribou decline and how we can effectively manage these populations. Declines in caribou populations are linked to human habitat alteration as well as natural habitat alteration. Here on the y-axis of the figure, the vertical axis, you can see the recruitment rate, the number of calves per 100 cows per year. And this is essentially a measure of new individuals being recruited into the population. With higher recruitment, typically the populations are doing better. There's more individuals to replace those that are dying. On the x-axis, we have anthropogenic disturbance. And what we see is that as we have more anthropogenic disturbance within a landscape, the populations in that area have a lower recruitment rate. There's also a signal of fire disturbance. In dark red, we have higher fire, and we see those populations have a lower recruitment rate than the populations with green, less fire. But by and large, habitat alteration is one of the main things that we're talking about with driving caribou declines. And if we look at this high disturbance, low recruitment rate part of the figure, we know that all of these populations are from Western Canada. Now, these declines that are linked to human habitat alteration are done so via predation, where increases or habitat alteration creates early cereal vegetation. If we cut down the forest, We get younger, more palatable forest growing in its place, which then results in higher abundances of species like moose and deer. And where there are more moose and deer, there are more predators like wolves and bears, which incidentally predate caribou. And this creates this apparent competition between moose and deer with caribou, where it looks like they're competing, but they're not actually competing for a shared resource. It's this shared predator that's mediating these relationships. One of the main disturbances that we're talking about in Alberta are these linear features. So cut lines through the forest used for oil and gas exploration, as well as other kinds of linear features like roads and railways. And I don't know about you, but if I'm plunked into a forest and I have to get around, I would much rather use one of these linear features than bushwhack through the forest. And if we put GPS collars on predators like wolves, that's exactly what we see them doing. So here, each of these yellow dots is a 5-minute location from a wolf GPS collared in northeastern Alberta. And just looking at this map, you can very quickly visually pick out these linear features. And not only are predators using these features to get around, but they're also traveling faster and farther when they use these features. So here we can see the traveling speed of wolves and compare the forest to the speed on conventional seismic lines. And we know that wolves are moving 2 to 3 times faster on these conventional seismic lines than they do in surrounding undisturbed forest. When species like wolves move 2 to 3 times faster, that means they can cover larger areas and increase their encounter rates with prey, which is essentially an increase in hunting efficiency, which is hypothesized to lead to caribou declines. This is also complicated by the fact that linear features that go through peatlands, which are historically kind of refuge for caribou habitat, wolves and bears will be more likely to use those peatlands when a linear feature goes through it. So they're moving faster and farther, and they're also using caribou habitat more as a result of these linear features. And despite these linkages between habitat loss and caribou declines, habitat loss continues. Here in this figure at the top, we see the net habitat change in caribou habitat. So below 0, there's a net habitat loss. Above 0, there's a net habitat gain. And Nagy Reyes et al. 2021 mapped out the net habitat change in all of the populations in BC and Alberta. And you can see each of those populations here along the x-axis, where many of the populations, almost all of them, have a net habitat loss. There are some populations in BC where there's been a net habitat gain over time. But if we look at Alberta specifically on the right-hand side of this figure, we see all of the populations, except maybe 1 or 2, have a net habitat loss. And those populations are losing their habitat despite the knowledge that that habitat decline or habitat loss is linked to caribou declines. And habitat loss is actually also continuing to accelerate over time, where the rate of habitat loss has been increasing over time. So what can we do about the decline in caribou? There are 4 main tools in our tool belt that we can use to manage and conserve caribou populations. The first is habitat restoration and protection, and that really gets to that ultimate cause of decline of habitat loss. The second is primary prey management, so things like reducing the density of species like moose and deer by increasing hunter harvest, for example, And the idea there is by decreasing the density of those species, we can then see a decrease in predators and an increase in caribou. More directly, there's predator management itself, where we can directly target killing predators like wolves to reduce those populations and relieve the predation pressure on caribou. The fourth is direct population augmentation of caribou populations themselves. So things like captive breeding programs, which you may have heard about coming online in Jasper, or things like maternity pens where we catch pregnant females, move them into a pen so they can have their babies in a safe environment. The calves grow up to an age where they're able to more successfully get away from predation and escape that predation, and then released each year. And we have seen a glimmer of hope with caribou conservation. Here I'm giving an example of the Klintsey-Zaw population in BC. If you are familiar to the caribou world at all, I'm sure you've heard about Klintsey-Zaw because the caribou folks like to focus in on those glimmers of hope, the rays of sunshine. And essentially what has happened in this population is the population was declining quite drastically in the late 90s into the mid and early 2000s until Indigenous-led recovery began and employed the management actions like maternity pens and predator reductions. And we've since seen not only the stability of that population, but an increase in the Klintsey-Zaw population. There's now over 100 individuals, whereas before we were down to, I think the number was 36, somewhere below 50. So that is a glimmer of hope in the caribou conservation world. Here in Alberta, most of our focus is on the two management options: habitat restoration and protection and predator management. So if you look into the Section 11 agreement for the conservation and recovery of woodland caribou in Alberta that was recently signed between the Government of Canada and Government of Alberta under the Species at Risk Act, you can see a lot of focus on these two main strategies. So I'll dive into those a little bit deeper. The first is habitat restoration, and this is what it looks like. When we're talking about habitat restoration for caribou, one of the main things, not the only thing, but one of the main things we're talking about is restoration of conventional or legacy seismic lines. Essentially, these seismic lines that were created for oil and gas exploration, and their regrowth has stagnated and they're not regrowing on their own and need a little bit of help to get there. So actions like mounding, tree planting, tree hinging are used to, in the short term, disrupt the use of these features by species like wolves and slow them down when they do use them. And then in the long term, facilitate that return to forest cover. So there's both short-term and long-term goals to these habitat restoration treatments. There have been some signals of short-term success. I say short-term because habitat restoration is really only starting to roll out in the last 5 to 10 years or so. And we've seen some good news stories with increased vegetation growth on these features and some signals of decreased use of these features by species like wolves and slowing down those species. So here, for example, Dickie et al. 2021 found some signals of reduced use in a treatment area relative to a business as usual area. So in the treatment area, all of these seismic lines were restored. And we did see some signals of reduced use by species like wolves, bears, caribou, and moose. There have been other projects that have also looked at these kinds of things and seen some signals of short-term success, but we don't have a great idea yet. I think I saw Aaron Tattersall sign in here. She led some of the work that was out of the Algar restoration area with Colburton and team. There's quite a few of these seismic lines across Alberta and BC's boreal. So here in this map in blue, we have the seismic lines within Caribou Range. In red, we have roads, pipelines, transmissions, and railway. And just looking at this figure, you get a little bit overwhelmed with how much work there is to do. There's hundreds of thousands of kilometers of seismic lines within Caribou Range in Alberta's boreal forest. So the question is, where do we start? There is a need to prioritize restoration, given how expensive it is. It can cost anywhere between $8,000 to $12,000 per kilometer to do restoration right now, though there are definitely lots of projects looking at how to be more effective at restoration or cost effective. It's time consuming, not only in the face of how many seismic lines can we restore each year, but it's going to take decades for some of these seismic lines to then fully return to forest cover. And there's an urgent need to stem these caribou declines now. We can't wait decades. So with Canada's Oil Sands Innovation Alliance, we at the ABMI's Caribou Monitoring Unit asked, in a working landscape, how do we prioritize restoration to get the best bang for buck? So taking caribou ranges and breaking them into manageable bite sizes, here townships, we can look at the current amount of habitat disturbance in each township, how much undisturbed caribou habitat we would gain by doing habitat restoration work, and then putting that in context of the cost of doing that restoration to understand the bang for our buck or the return on investment, and prioritize townships that'll give us the highest bang for buck by doing habitat restoration. I won't get too into the details of that work, but essentially we mapped out each township and prioritized them into zones 1 through 5, zone 1 in dark green being the highest restoration priority, using this kind of idea of bang for buck and including weightings like where caribou habits or where caribou are using right now. Let's focus in or weight higher townships where caribou are using those areas more frequently, and decreasing the weighting of areas that are more likely to be redisturbed in the near future by incorporating resource value. So a measure of the amount of oil and gas under the ground. So we've done that in all of the caribou ranges in northeastern Alberta, and have recently also done a very similar exercise in northwestern Alberta with the Northwest Species at Risk Committee. And we're also expanding that into BC's boreal and mountain populations now as well. But even within each of these linear features within the townships, not all linear features are equal. So what do I mean by that? We know that wolf speed is slowed considerably when vegetation exceeds 50 centimeters. So here, if we look at the schematic, we see that wolf travel speed decreases as vegetation height increases, most dramatically, even with just a little bit of vegetation height. So this is the 50 centimeters. And then it slowly begins to plateau until it reaches that same speed as we see in the forest at around 4 meters. And we can kind of start to use this information on when we expect to see the biggest slowdown in wolf travel speed to then prioritize specific seismic lines for restoration within townships, for example. But in order to do that, we need up-to-date vegetation data. And there are a number of remote sensing tools that can help us answer those questions. And one of the things that ABMI is really starting to work on now is using Things like aerial imagery to understand the vegetation community that is regrowing on disturbances in the boreal. So, for example, ABMI and the Northwest Species at Risk Committee last year did a pilot in the Chinchaga and Caribou Mountains ranges to map out the vegetation community and height of vegetation on seismic lines in these pilot areas. And we can start to focus in, for example, on prioritizing restoration in the seismic lines that are yellow, which are less than 1.5 meters, compared to those few seismic lines that already have vegetation exceeding 5 meters over here. By doing this kind of exercise, we can assess critical habitat and start asking questions like, can we demonstrate progress towards the federally identified 65% undisturbed habitat threshold or target by identifying natural regrowth that's already occurring on some of these seismic lines? How many of these seismic lines are already regrowing? We have some broad ideas of what that looks like, but data are not collected in an up-to-date way, nor are they high resolution across entire caribou ranges. We can also use that kind of information to restore disturbed habitat. So as I was pointing out earlier, identifying lines that specifically need treatments to help that return to forest cover. We can also use it to monitor restoration over time. Things like establishment surveys and understanding how vegetation is regrowing following restoration can happen by reflying or re-inventorying lines over time in some established time span, like every 5 years or every decade, to really get an understanding of how restoration is increasing vegetation regrowth and what kinds of treatments are more effective. So now that I've talked about habitat restoration, I'm going to change directions a bit and talk about predator reductions, which is the second tool that Alberta has largely focused on. And that the idea behind it is reducing predator densities by killing individual predators to relieve that predation pressure on caribou. And because I don't think anybody really likes the idea of killing one species to save another, if you will, we have to be sure that we're asking the question, does it help caribou? And there's been quite a bit of work that is monitoring caribou response to these management actions, both in Alberta and BC. I'm going to give an example that's coming out of BC now that you may not have seen with the South Peace Caribou Recovery Program. So those populations in the South Peace region were declining over time. So here we have the population estimate of caribou. And on the x-axis, we have time, and we see caribou populations decreasing. Wolf reductions began in 2015, and following that, we see an increase in caribou populations over time relative to the estimated kind of projected decrease that would have happened had the pre-wolf reduction trend continue. And we can also take this kind of information and project it out over time. And we see that we would have expected the populations to become extirpated prior to 2050, whereas with wolf reductions, if the current trends continue, we expect the populations to continue increasing and eventually, hopefully, stabilize at a higher level. But we need to make sure that as we're conserving caribou populations and using these management actions that we're learning from them. So how do we conserve caribou while simultaneously learning? Well, we can use the ideas of Graham Colley, who asked the question, why is a population declining and how can we prevent further declines? So really getting an understanding of why the population is declining to most effectively prevent those declines. We can also borrow the ideas of Carl Walters, who suggested the idea of learning by doing or adaptive management. And this is essentially that an understanding comes from ongoing adaptive and an experimental process where rigorous science can be used to not only apply experiments to conserve populations, but learn about the mechanisms behind those declines and how to more effectively manage the populations at the same time. I'll give an example of kind of this learning by doing from Soroya et al. 2019 in mountain caribou populations in Alberta and BC. So in green, we have the control populations, where each of these green populations of caribou had no active management kind of being conducted at the time. And what we see is that all of these green populations had lambda less than 1. So lambda is the population growth rate. It's less than 1, that means the population is declining. If it's greater than 1, the population is increasing. All of these control or reference populations had a lambda less than 1 at the end of the study period. 4 of the 6 populations decreased from the beginning of the study to the end, and 2 out of 6 increased from the beginning of the study to the end, but were still declining. If we look at translocation, there's one case where translocation was used. In this one case, we did not see success. Lambda or population growth rate was less than 1. The population was declining. And in fact, the population has since become extirpated or functionally extirpated. Moose removals in yellow, if we focus in on that tool, we see that by the end of the study, 3 of 4 populations were still declining, whereas 1 of the population, we see that kind of glimmer of hope start to enter with the population increasing, lambda over 1. And 2 of the 4 populations actually increased from the beginning of the study period to the end. So we start to see some signal of success with moose removal, but quite a bit of variation. We then look at wolf removals in red. We see that now only 2 of the 6 populations at the end are declining, whereas 4 of the 6 populations are increasing at the end of the study. And 5 of the 6 populations where wolf reductions occurred increased from the beginning of the study to the end of the study significantly. So we start to see a little bit more hope, at least for caribou, from wolf removals. And then that main glimmer or beacon of hope that we all in the caribou world like to look at, the Clinzy-Zaw population, where maternity penning and wolf removals were used simultaneously. Though that population, as I said, is increasing over time and significantly so, which kind of suggests that combining management actions is more effective than any one management action on its own. At least the combination of maternal penning and wolf removal had the strongest effect relative to the other treatments. Now, this study focuses on population management actions, either of caribou, the predators, or moose, but does not look at habitat restoration. So what do we know about the effectiveness of habitat restoration? The largest scale habitat restoration program to date is by the Regional Industry Caribou Collaboration, which is a group of energy companies and forestry companies in northeastern Alberta. And through this program and the individual member companies' actions, over 1,800 kilometers of linear features have been treated to date. This is where both Cole Burton and Aaron Tattersall's work in Algar comes in over here, as well as the other study that I mentioned with Synovus and the linear deactivation program over here comes in. And the linear deactivation program and a lot of the work that was done in the east side Athabasca Caribou Range and Cold Lake Caribou Range was poised and set up for pulsed monitoring of vegetation, animal use of lines, and animal densities over time. So the goal was to really monitor that long-term response, see if we're seeing increased vegetation growth. Are we seeing decreases in animal use of these seismic lines? And ultimately, and arguably most importantly, are we seeing changes in animal densities over time and as larger areas become restored? Do we see those wolf populations come down, and do we see caribou populations increase? So that's really that treatment. And then we can look at neighboring populations for controls to really understand and learn by doing. Now, in 2017, the government of Alberta began a wolf reduction program in Eastside Athabasca and Cold Lake. So now this large-scale pulse monitoring of vegetation and animal use of lines and animal densities as habitat restoration expands over time and space is confounded with that reduction in wolf densities, which is, of course, great in that it reduces the predation pressure on caribou, but we no longer are able to specifically learn about large-scale habitat restoration from this program. So we're left wondering if it's going to be effective, at least at reducing animal densities. So moving forward, what are the big unknowns in caribou monitoring and conservation? First, what is the status of human-altered habitat in Alberta? How much of it is regrowing or growing on its own? And how much restoration is needed to outweigh new disturbance? We want to see a positive trend in caribou habitat, but we're not able to really understand when we'll get there or how much work is needed to get there if we're not monitoring that. And we are, of course, monitoring new disturbance and restoration treatments, but we don't have a great sense of the natural vegetation recovery on many of these features. The next unknown is, do habitat restoration and wolf reductions work for boreal caribou, particularly in the northern boreal populations? We need to make sure these management actions are being effective. Wolf reductions, of course, have a social cost as well as a monetary cost. Habitat restoration is expensive to conduct and it takes a long time. So as we're doing these things, we need to make sure we're being as effective as we can be and seeing the responses in caribou populations that we're hoping to see. And restoration is currently not occurring in isolation at a large scale. So we really have no way of knowing if it's being effective. There's currently an assumption of build it and they will come, that habitat restoration can reverse all of these pathways that human habitat alteration has disrupted. And while I'd love to think that's true, we need to make sure that we're actually testing that. And then the elephant in the room is, how does climate fit into all of this? We hear about climate change all the time in our daily lives, and we know that climate change is happening. And so far, I've only been talking about landscape change as a result of human habitat alteration and kind of a little bit with fire. But what about climate? Well, we know climate and variation in weather does in fact influence caribou populations. That's not particularly new, but what we do know now is that in these boreal populations, adult female survival decreases with colder winters with higher temperature variability, but increases adult female survival is higher with longer, warmer growing seasons. So what we've seen is adult female survival is influenced by climate quite a bit. There's still a lot of variation that's not explained by climate, but there's still a fairly big change here in adult female survival with climate. And the same goes for calf recruitment, where longer, more productive growing seasons in the fall prior to birth leads to higher recruitment rates. So recruitment rates are higher when the year prior to that calf being born had a longer, more productive growing season. So we need to keep climate in mind when we not only evaluate these kinds of other management actions, but also when we're planning management actions. So southern populations, for example, are more strongly influenced by plant phenology, which really starts to bring in thoughts about poor forage conditions and how those may be exacerbated by increased risk-sensitive foraging in these southern populations that have high densities of predators. Conversely, northern populations are more strongly influenced by colder and more variable winters. So these populations are likely vulnerable to an increase in freeze-thaw events, which are predicted to occur as climate change occurs. So not only do we need to keep these kinds of variations in climate and habitat alteration in mind for caribou specifically, but we also have to be cognizant that climate and habitat alteration are confounded in space and time. So for example, here in Alberta, we see that human habitat alteration in dark red decreases as we move farther north. And climate becomes harsher, particularly winter harshness or temperature in this example, changes as we move northward as well. So we need to keep climate in mind when we talk about any kind of relationships with habitat alteration. And an example that we're really thinking about here at the Caribou Monitoring Unit right now is the expansion of white-tailed deer populations, which are really just budding up and starting to really get into caribou habitat in the northern boreal forests. And these populations of deer, if you think back to the beginning of the presentation, are linked to increased densities of predators like wolves and declines of caribou. So we need to understand the relative effects of human habitat alteration and climate change when we're talking about these complex pathways and how to manage them. One example of a project that we're doing right now to disentangle these effects with white-tailed deer are with camera traps in northeastern Alberta and neighboring Saskatchewan, where we're contrasting caribou ranges with high human habitat alteration in Alberta to neighboring Saskatchewan, which has low habitat alteration in gray shading, but very similar climates, to really get at that relative effects of climate and habitat alteration on those expanding white-tailed deer, for example. So with that, I'd like to say thank you for being here and listening to this presentation. I look forward to questions that you may have, and I want to say thank you to all our project partners. You can go to our website, cmu.abmi.ca, for more information about our program and our projects. You can also feel free to get in touch with me by email or even Twitter. So with that, thank you.